Good morning and good afternoon, RSGA STEM classes, and whoever decided to watch this video. And welcome to our multi-video series on STEM around us. The objective here is to look and observe how STEM is around us in our everyday lives and to kind of put together the pieces of a puzzle for a possible career within the STEM fields. So I hope you're able to take something from this, and let's go ahead and get started. We're going to start off this series by going on a little scavenger hunt. Now, this scavenger hunt doesn't require us to leave our seats. We're going to discover that your home is actually filled with some of the oldest and most important inventions in our history. And that invention is simple machines. Now, there's multiple machines here. It's not just a simple machine, but simple machines plural. By the end of this lesson, I hope you're able to discover that you'll never look at some things that we take for granted the same way again. So what exactly is a simple machine? Well, in reality, it's a mechanical device that changes the direction or magnitude of force. In other words, it makes work easier. There are really 6 types of simple machines. We have the lever, the wheel and axle, the pulley, the inclined plane, the wedge, and the screw. Scientists have known about these for thousands of years. The ancient Egyptians even used these machines to help build buildings such as the pyramids. The lever is really your first power tool, if you want to think of it like that, right? So think about this. On a playground, you see a seesaw. We all know what those are, right? The seesaw really has 3 parts. The fulcrum, which is the pivot point in the middle, and the effort, which is the force that is applied, and of course, the load. Now, if you have 2 people on the seesaw, you know that effort comes both ways. But if you want to think of it as a static weight, such as the pictures on this image, you could think of it that way. Now, here's the cool part. By changing where the fulcrum is, or that center pivot, you can lift something really heavy with little effort. That's why some scientists say, give me a lever long enough and I can move the world. Levers are in a lot of different places, but let's focus on the kitchen. Think about scissors. All right, that is 2 levers working together. Bottle opener? Yeah, that's a lever. Put the tongs that maybe you use for cooking or for grilling. Those are 2 levers, right? 1 single fulcrum. Even a can opener uses lever action to help squeeze and cut the ends of a can. So the next time you're in the kitchen, count how many levers that you observe. I bet you'll find quite a few. The wheel and axle might be one of humanity's greatest inventions. It is basically a wheel attached to a rod. That rod is the axle. You will find this with steering wheels, moving cars left to right, wheels on cars themselves, which are definitely wheels on axles, doorknobs, and can openers. And again, the can opener in this case is not the lever part, but the part that twists. Now, thinking about that doorknob, your door handle is a perfect example. It's a knob, that's a wheel that goes into the door, and the part that goes into the door is the axle. And that axle is attached to a latch, which allows the door to become locked and unlocked, or latched and unlatched. Fantastic designs and really brilliant if you think about it. Now, try opening a door without the door handle when it's still latched. It's not going to work very well, right? Thus, the brilliance of the wheel and axle. Some might think pulleys are like magic. In reality, they help us lift things easier. All right. All they use is a rope or a string and a wheel to slide inside of a groove and help lift things. A fixed pulley kind of works like on a flagpole, or you see these on flagpoles. They change the direction with the force. You pull down and the flag goes up. Real simple, right? A movable pulley actually reduces the force that's needed for the change in direction. Construction workers use these steel beams that weigh thousands of pounds, and because of pulleys, it makes their job so much easier. In fact, I bet that if you have blinds in your home, there's a pulley in there somewhere. Believe it or not, there is a big similarity between inclined planes, wedges, and screws. They're all related, and they're all related based off of, well, the inclined plane, which is just a fancy word for a ramp. Ramps usually give us an easy way to push something to different heights, all right, instead of lifting straight up. That's one of the reasons that wheelchair ramps exist, to help push something or someone from one height to another. Alrighty, now a wedge is like two inclined planes or ramps stuck together at a point. Think of it as a knife or an axe. You swing that axe down, it hits wood and it splits the wood. Then there is a screw. That's an inclined plane wrapped around a cylindrical object. So look closely at a screw sometimes, and you'll see that there is a ramp spiraling around it. Now that's a little bit different than a nail, which gets put in straight with a hammer. There's no twisting motion, right? That screw allows us to twist the object in to hold two pieces together. So what does it all mean? Well, simple machines aren't just old technology. They are everywhere around us. A bicycle by itself contains and combines wheels, axles, and levers. A construction crane uses pulleys and levers. Even standard playground equipment uses simple machines. These innovations are the building blocks for almost every complex machine that we use today. So let's make a connection with our careers. If you like figuring out how things work, careers in mechanical engineering, product design, or construction might be right up your alley. Mechanical engineers design everything from car engines to robotic arms, all using, guess what? Simple machines. Product designers create the tools we use in our everyday lives. And of course, construction workers use simple machines to build our homes, schools, buildings, and bridges. That brings us to the end of video 1. Make sure you check out the next video in our series.